Try this again. Cheese. All right, we are recording. Let's go. Share screen. Ba-ba-da-ba-da. Grab your graph paper if you need it. Okay, here we go. So go ahead and copy this equation. We are graphing. All right, and just before I forget, as we graph this, we're going to create a table of values as we go. So one of my requirements for graphing is create a table of values. So I'm just going to start my table of values down here. So as I find anything, I will fill it in. Okay. Before we even touch the graph paper, look at the equation. What things do you know will happen with the graph? Or what things do you predict will happen with the graph, or like you think will happen with the graph? So look at the equation. Just by looking at the equation, tell me anything you know for sure or you think might happen. You can just say it or you can put it in the chat. Just by looking at the equation, there's a few things we know are either going to happen or we think are going to happen. Okay, so some people are saying odd degree. So that's an observation of the equation. Odd degree, what does that mean will happen with the graph? Odd degree, what does that mean will happen with the graph? And someone's saying arrows are going to go in opposite directions. So opposite arrows, right? So one arrow will be going up on this graph, one arrow will be going down on this graph. Tell me something else about the arrows before I move on to the other things you guys are saying to me. Something else about the arrows. I know it's hard to describe in chat if anyone's willing to unmute. Something else about the arrows.
They are going in a positive slope.
Good, good. And how do you know that? How do we know?
Because the coefficient of the x to the third is +1.
Perfect. So because this number is positive, we have a positive leading coefficient. That tells me, we got lots of arrows going on here. That tells me that the arrows are going to be in this format, right? It's like a positive slope from left to right with something happening in the middle, right? We don't know exactly what's going to happen in the middle, but this is what's going to happen. Someone also said that there are going to be 3 points on the x-axis. So 3, I'm going to add to this 3 or less x-intercepts. I know there's going to be 3 or less x-intercepts because of the degree of the problem. So if the degree is 3, 3 or less intercepts. Or less because some of them might be imaginary, or some of the x-intercepts might be a double root. So that would cause there to be less than 3. But that's what we're predicting will happen, 3 or less. Now, just a warning, don't do this. Sometimes people mess up their arrows, and like, let's just say the problem was a 4th degree and you knew both arrows had to be down, down. There's sometimes people do this and they're like, hold on. There was a point I was trying to make and I don't remember what it was now because that's not what it was. I don't remember. So I'll come back to it later. I had a point. I forgot it. Okay. And then there was one more thing someone said. Perfect. 0, 3 is the y-intercept. So this constant is our y-intercept. Okay. I know that because in order for something to be a y-intercept, you make the x value 0. And if you make all the x's 0 in this equation, all you're left with is that constant. Remember that in a quadratic, the c value was the y-intercept. The same thing happens for any polynomial. If it's a cubic, a quartic, a quintic, a 12th degree, a 20th degree, doesn't matter. this C, the constant, is always the y-intercept for polynomials. All right, so these are a bunch of things that we know either are going to happen for sure or we think will happen. The only one we think will happen is the 3 or less. Like that one, like we're not sure what's going to happen, but we're guaranteed about the end behavior arrows and we're guaranteed about the y-intercept, right? So we know a bunch of stuff even before we do the graph paper. If you wanted to, you could graph your y-intercept right now because we will use it. I'm going to save it for later. So once you kind of make all your predictions and you're ready to get going, we are going to start this problem by finding those x-intercepts. Okay, in general, not for this question specifically, but in general, how do you find an x-intercept? Think about like the most general answer you can give me, not specific to this question. How do you find an x-intercept?
Make y 0.
Make the y value 0. Perfect. Okay, so we are going to make the y value 0. That goes for any math problem. If someone says find the x-intercept, you say, okay, I got to make the y value into a 0. So the y value in this question is that f of x. This is where Miss Ingle gets picky, right? Some of you have learned that the hard way on tests and quizzes. If you lose that equals 0, equals 0, equals 0, right? I deduct points for that. It's so super important to the whole math world. Okay, so now we've set it equal to 0, and now you're going to solve. How do you solve? Well, that's going to change from question to question, depending on what polynomial you have in front of you. Here are some choices of how to solve. You've got, if it's a quadratic, you've got quadratic formula, double bubble, completing the square, square root method. If it's bigger than a quadratic, you've got quadratic form questions. You've got grouping method. You've got GCFs. You've got sum and difference of two cubes formulas. Those are your SOAP formulas. You've got rational zero theorem. Those are all the ways you might have to solve. So look at this one and go ahead and try to solve using one of those methods. If you get those x-intercepts, you can go ahead and put it in the chat. I can give you a little thumbs up or thumbs down. We're looking for three answers. I'm just gonna check and make sure Jaden's okay. Artisha, perfect. Go ahead and start to plot them. Are you good? Good, good, good. Everyone who typed in the chat so far, you're correct. Go ahead and start to plot those points onto your graph paper.
Miss England, are we also going to find like the local maximums and minimums?
We're going to talk about it. Yeah, we're going to talk about it.
Okay.
Okay. Yes. Okay, so for anyone who's struggling, grouping method should work. Grouping method does work, since I should. Grouping method does work. You need to factor out a -1 on the last two terms because you need those bubbles to be the same. So a very important comment, and I've made it before, but I'll say it again because people still had trouble with this on the quiz. When you do grouping method, those two bubbles have to, must, there's not an option here. Those two bubbles must be the same to keep going further with this question. If you have one bubble that's x plus 3 and one bubble that's x minus 3, grouping method doesn't work. You stop, you either made a mistake or grouping method doesn't work. They have to be the same, okay? So my bubbles are the same. I'm going to take that bubble, put it in front. And then the two remaining terms become a separate bubble. So one answer is x equals 3. The other two answers come from this quadratic. You can solve this quadratic either by doing a difference of two squares, or you could just do square root method.
Miss Ingley,
Yep,
I have two questions.
go ahead.
So the first one is about how many points do you need to graph?
Okay, and what's your second one?
Can I go print my graph paper?
Of course. How
Okay.
many questions you need to graph? I'm going to go over that in a second once we start the graph paper.
Okay, thank you.
Yeah. Okay, so I solved this, with square root method. You could also solve this little portion here by doing difference of two squares. So altogether, we got 3 x-intercepts right now. I'm going to put them into my table of values. So we have 3, 0, 1, 0, and negative 1, 0. I'm going to plot them on my graph paper. All right, I'm going to pause just to make sure everyone's caught up before I start to explain the next step. All right, any questions up until this point? Okay. All right, so we know what the arrows are already going to do. Don't do this right now because I'm going to erase it. We already know this arrow is going down and this arrow is going up. So we could just do this. Boom, 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 done, right? We're not going to do that. We're not just going to make like a random squiggle. We want to make it just slightly more accurate, okay? This is accurate. This is a sketch. It's not wrong, but we want to make it just a little bit better, okay? And the way we're going to make this graph a little bit better is we're going to add some extra points to it. So he was asking, how many points do we need? Right, so the Mrs. Ingley rule, and I think it's the same for other Algebra 2 teachers as well. The Mrs. Ingley rule for how many points do you need? You need all your x-intercepts, kind of a duh, right? Duh. And you need an additional point in between each set of x-intercepts, right? So you have 3 x-intercepts right now. You need something in between these two, and you need something in between these two. So you have to fill the gaps in the middle. So for this graph, you're going to have a total of 5 points. The 3 x-intercepts, and then 2 more additional points to fill the spaces. If we had another x-intercept, you would add another additional point in between those two. So if you had 4 x-intercepts, you'd have a total of 7 points altogether, right? The 4 x-intercepts and the 3 points in between. So that's the golden Mrs. Ingley rule for how many points do you need. So good news is we already have one of those filler points, our y-intercept, 0, 3. I'm going to add that to my table of values. So that takes care of the space in between those 2 x-intercepts. So now we're going to look to fill the space in between 1 and 3, right? We have x equals 1 and x equals 3. Pick any number in between that. Pick any number in between 1 and 3. I'm going to guess we all picked 2, right? It doesn't have to be the midpoint. It could be anything in between. So in between 1 and 3, you could have picked 2.5. I don't know why you would, but you could. So go ahead and plug 2 in. You can plug it in your calculator, or is anyone a huge fan of synthetic substitution? Right, so 2, -3. I'm wondering if I beat some of you who are still trying to grab your calculator. Oops. So 2, -3. Right, and those are my 5 points. Those are my 5 points. Now I'm going to connect the dots. When you connect the dots, oh my goodness gracious, some of you get very creative in your connecting the dots. Please don't do something like this. What is the big red flag that says this is wrong? Like I would write red flag on your paper. And then what would I write underneath that? Like, why is this a red flag that it's wrong?
It doesn't, like, it's not a function.
It's not a function, right? It's not a function. And the topic of this chapter is polynomial functions, right? It doesn't pass the vertical line test. So this is a big, like, no way. What were you thinking? No offense. So how do you connect the dots? You connect the dots from left to right, from left to right. So if I had to number the dots, it would be 1, 2, 3, 4, 5. Right? That's the order in which you're going to connect them, from left to right. If for some reason visually you have trouble with that, feel free to write the numbers 1, 2, 3, 4, 5 like that. If that you find that helpful, go ahead and connect your dots.
This is Ingley.
Yes.
Yeah, so I printed my graphs. How much? So you need 5 values in the table.
You need all your x-intercepts, right?
Okay.
And then you need additional points in between each set. So if we have 3 x-intercepts, you need to fill like a space in between those 2 and a space in between those 2. So this graph needed 5 points. If we had another x-intercept, you would need an additional x-intercept and then an additional point in between those 2 x-intercepts. So you would need 7. So
okay,
each question, how many points are needed will change based on how many x-intercepts you have.
Okay, thank you.
You're welcome. Okay, now let's talk about turning points, right? This graph, this is your vocabulary that you learned last night. This graph has 2 turning points. There's one right here and there's one right here. Turning points become either a local maximum or a local minimum. This graph does not have a max. It does not have a maximum of the graph because of this arrow is going up forever. So there is no maximum. There's also no minimum because this graph is going down forever. So there is no minimum. However, there are local maximums and local minimums. And that's what the video last night talked about. So I'm not going to go into detail repeating myself. So this is a local maximum. So if I asked you like identify all the local maxes, you would say local max at 0, 3. And if I said identify any local minimums, you would say local minimum at 2, -3, right? Now, when you actually graph this, let's say on a graphing calculator or a website like Desmos, right? Like a graphing software, this graph that we've drawn by hand might not be perfect. It should be pretty accurate. I mean, we have for sure, we know those x-intercepts are correct. And for sure, we know our arrows are going in the right direction. And for sure, we know that the graph passes through 0, 3, and we know for sure that the graph passes through 2, -3. Well, we don't know for sure if these are actually the real turning points. And guess what? They're not. These are not the real turning points. This graph does not turn at 0, 3. It actually turns, it's very close. It actually turns, it didn't really look any different. It actually turns slightly before 0, 3. I don't know what the ordered pair is, but let's just pretend like -0.1, 3.1, right? So it's pretty close, but it turns right before it hits 0, 3. How are you supposed to know that? Either calculus, which you haven't learned yet, or a graphing calculator, which we're not using at this point. So based on your graph, you think the turning point is 0, 3. That's what you're going to tell me. Okay. But I want you to know that these turning points might not actually be the real turning points. Okay. It's just a sketch. This is our best guess with the knowledge we have right now. Any questions about anything I've said? Okay, last thing I want to do with this before we try one more is describe the end behavior of the graph. So if I was doing this question on a test or a quiz, what I would do is I've memorized that little sentence. As x approaches positive infinity, that just means as I look to the right, x going to the right, the function approaches. So as I look to the right, where is the function going? It's going up. So up, we're going to say positive infinity. Then I'm going to go the other direction. So as x approaches negative infinity, which just means as I look to the left, right? That's what that means. The function approaches, where does the function go when I look to the left? The function is going down. So the y values are headed towards negative infinity. So this highlighted piece that I'm highlighting right now, that's like I can memorize that. And then all you have to do is fill in those blanks at the end, right? That's going to change from question to question. Again, your book does this reversed. They reverse the sentence, which I do not care for. All right, let's try one more. And then we're done. Everyone good? Super excited about this? Well, you're going to be even more excited when you start this problem. You'll see why in a second. Go ahead and start it. Yeah, buddy.
I didn't find the big piece of paper, but I found my calendar.
Okay, that works.
And this is my mug.
Oh, we drew a picture of a mug. I don't know if you guys can see me. You drew a picture of a mug.
On a table.
On a table. What was the assignment? What did you have to draw?
Draw a mug on a table.
Oh, that's what she said to draw? Draw a mug on a table. Okay, well, you did a great job of drawing a mug on a table. What's this? Is this a donut?
No, that was...
You messed up?
A big mug.
Oh,
I messed up.
Oh, you made it too big.
Mm-hmm.
Got it. It looks like a mug with a donut. Now I want a donut.
We can pretend that's a donut.
I think we should.
We should pretend that it's a donut.
And someone took a bite out of it. Yeah.
Right.
Glad he's happier. Okay, how are we doing so far? Did you start by hopefully making some predictions about what the graph looks like? So maybe you said, oh, odd degree with a positive leading coefficient. I know my arrows are going to do this. And what else do I know? I know there's going to be 3 or less x-intercepts. I know the y-intercept is 0, -6. Maybe some of you just jumped right to let's solve for the x-intercepts. You got super excited about it. Is anyone like staring at this and being like, oh, this is bad news. Oh man, what's the bad news? The bad news, grouping method doesn't work. Grouping method doesn't work. It's not a quadratic, so I can't do any of my quadratic skills. It's not a quadratic form. There's no GCF. It's not a sum or difference of 2 cubes. What do I have to do? Oh, isn't that painful to say? The rational zero theorem. I have to do the rational zero theorem. Oh, goodness gracious. Some of you are like, what's the rational zero theorem? That is the P over Q thing. Remember that P over Q thing we did the 2 days before Christmas break when you were probably already mentally on Christmas break? Yeah, well, here it is to bite you in the tushy. P over Q, here we go. Here's your recap. We're going to make a list of possible guesses. So your P is your constant. Your Q is your invisible leading coefficient. And you're going to make your list of P over Q factors. Plus or minus 1, 2, 3, 6. Factors of Q, plus and minus 1. You then divide all your P's divided by your Q's, which in this case is silly, but I'm going to do it anyway. This way you don't forget to do it for other problems when maybe your Q is bigger. So we have a total of 8 possible rational zeros. So these are 8 guesses. So start guessing, pick a number, either put it into your calculator or do synthetic division. I'm glad I couldn't hear all your moans and groans once you realized what we had to do. Oh, this is exciting. Look at this. Woo woo. Yay. First guess, I found it. So what does that mean? That means that x equals 1 is one of my x-intercepts. So I'm going to start my table of values and get that guy plotted. So I need 2 more x-intercepts. I got 1, I'm looking for 2 more. To find the 2 more, use the depressed polynomial, right? So don't start over again guessing and checking. Take the 1, 5, 6, depress your polynomial, and now solve this depressed polynomial. Good news is it's a quadratic, so you've got lots of options. Double bubble, square root method, difference of two, completing the square, quadratic formula. Go for it. Right, so I've got all 3 x-intercepts now. Now I just need to fill the gaps with my additional points. I already have 1 additional point, my y-intercept from the beginning of the question, 0, -6. I'll get that guy plotted and into my table of values. And then I need 1 more additional point. I need something in between -2 and -3. So you can pick any decimal in between -2 and -3. And I'll allow decimals for this. So I'm assuming everybody's going to pick -2.5. Unless you are just, I don't know, feeling a little, what's the word? Adventurous? I don't know. So I'm going to do that for you. So -2.5, when you plug it in, you should get, so maybe I'm not going to do it for you. I think it's 0.875. I don't have the paper in front of me. I think it's 0.875. All right, and then we know what our end behavior looks like, right? We predicted that at the beginning of the question. So get 1 arrow going down, get 1 arrow going up, and then connect those dots from left to right. Remember that this is just a sketch. So I often get the question, something like this. How do I know if this arrow goes like this, or if this arrow goes like straight up in the air? How am I supposed to know? The answer is you're not supposed to know. Like, you would have to either get additional points, you would need a graphing calculator. This is a sketch. So as long as your arrow is going up, I'm not going to say like, oh no, it was supposed to go up steep or it was supposed to go up wide. You're not expected to know that. Okay. Questions? I have one more thing to tell you before I get rid of you.
Yeah, I have a question.
Go ahead, Jitesh, go ahead.
Okay. So for the local, for the maximums and minimums, if the graph extends to positive and negative infinity, do you just put like positive infinity as the maximum, or do you put no maximum and no minimum?
If the graph extends to positive and negative infinity, you say no max and no min.
Okay.
So any odd degree, so 3, 5, 7, 9, they have no maxes and no mins because we know what those arrows are going to look like. You will only have a max and a min for even degree functions. So quadratics, quartics, 6th degree, 8th degree, those will have maxes and mins. Yeah, but not odds. You will have local maximums and local minimums anywhere you have a turning point. So in this graph, you have a local maximum at negative 2.5 comma 0.75, and you have a local minimum at 0 comma negative 6. Was 0.875 correct? Someone's saying that they didn't have that, but I have the paper over here. Whoa. Let's just double check. No, 0.875 is what I have on my paper. I'm pretty confident in that. Check your parentheses. Make sure that your parentheses are accurate because that could be making a difference. I'm pretty confident in that, but I'll double check after. Okay, last thing I want to tell you guys, just look for right now, and then if you want to copy something from what I'm saying, you can. On the homework, you're going to graph 2 questions. That's it, just 2 questions. Let's just, go ahead. Oh, sorry, go ahead.
I had another question.
Go ahead.
So if you give us a quartic expression, right, and your requirements is all of the zeros and then like 2 more, I think. So would you want us to do 5 of them and then like 2 more at the end?
Okay, so so for a 4th degree, so a quartic, you would have 4 ordered pairs as your x-intercepts, most likely. And then you would have 3 additional fill-ins. So your table of values should have a total of 7.
I meant the 5th degree.
So 5th degree, you would have 5 x-intercepts and then 4 like filler points. So you would have a total of 9.
So you want us to write 9 of the points down in the table?
Yep, you got it.
Okay.
You got it. So how many points changes from question to question, right? Yeah, so all the x-intercepts and then a point in between. So the one thing I want to show you guys is on the homework, you might have, the homework doesn't have a 4th degree, but I'm using a 4th degree as an example. 4th degree, we're expecting 4 zeros. But what might happen is you might end up with something that has like a double root, right? That's a possibility. That's how you could get 4 or less, all right? So let's pretend that happened. Right? So 1, 2, 3, 4, 2, and negative 1. Let's also say that your leading term was like a 5x to the 4th. So you know the arrows are up, up. Okay? If you just go and connect the dots, this was the point I was thinking about earlier. If you just go and connect the dots without actually thinking, you might do this. Right? If you put no thought into this, you might do this, which is really wrong because you know your arrows should turn up. Some people say, okay, I know the arrows are going to be up, up. So they go and they graph it like the way I did, and they're like, wait a minute. Something's not right. I know it has to be up, up. So here's how they fix their problem. I'll just turn this up. That's not good. Why is that not good? Because you just added an extra x-intercept where there's not supposed to be one, right? We knew that there were x-intercepts at these 3 places. You can't just add another x-intercept wherever you feel like, okay? So here's what happens. When you have a double root, something a little bit funky happens. -1, 2, and 4. when you have a double root, the graph doesn't actually cross the x-axis.
Mommy.
Instead, the graph touches it and then like bounces back. And that's how you end up going up, up. So I have 3 x-intercepts, and at the double root, you just like touch it and then curve. You never actually cross. Okay, so that's gonna happen on one of the homework problems tonight. So just keep an eye out for that. All right, perfect timing. There's our bell. So homework is posted. If you have any questions, I'm here. Otherwise, goodbye. See you guys.